The big recording button is pushed. We are live on Twitter Periscope. Good evening, everyone. My name is Elias Prunin. Welcome to the stream. So tonight we're going to take a look at the Phidgets Getting Started Kit. I first saw these at the Bring It Together, the Educational Computing Organization of Ontario's yearly conference. Went to a session and just fell in love with these devices. They are super, super cool. I've been experimenting with them for the past couple of days. So why don't we just get started with what are these things? What is in this box? What is in the Phidgets box? What do you get in the Getting Started Kit? And why do you want to use one of these? By the way, if you want to get your own Phidgets Getting Started Kit for your classroom, you can go to phidgets.com, phidgets.com. Lots of fun. So what do you get in these boxes? Why do you want to use these? Well, first off, let's talk about why you might want to use something like Phidgets instead of, say, an Arduino. So I've got an Arduino. Oh no, I did have one just beside me a couple of minutes ago, but I appear to, oh, no, there it is, just hiding behind a bunch of equipment. So like right here, I've got just a really bog standard Arduino Uno here. You know, nothing too special. This is pretty much what you would get out of the box if you bought an Arduino. And these are great. These are great little embedded devices. But they do have a little bit of a learning curve. So for example, if you want to learn how to program on them, you have to get the environment set up. It's not too difficult to get the environment set up. You're coding in a lower level language like C or C++. That can be a bit of a barrier to entry. And then if you're going to be wiring up, say, anything like a joystick hat or any sort of LEDs, you're going to have to get into the world of electronics design. And you have to get to know, like, okay, well, if I'm going to use an Arduino, you know, like what resistors and what parts am I going to use? Do I need a 100K? Do I need a 10K? Like, what am I going to need to use for this thing? So there's a fairly high barrier to entry with an Arduino. Not nearly as high as it used to be, but you know, it's still there. So that's a thing. But getting back to the Phidgets, the reason why these can actually be so cool instead of using just trying to use a Arduino is just they are super simple to use. They're super simple to get started with. It's literally plug and play. They're so cool. I'm just going to go into producer view here for a second, just so I can actually see what's going on and react to people and say, and say things. Okay, perfect. Okay, so I was just talking about the Phidgets. Why would you want to use them? Let's get this Getting Started Kit open and actually see what you get in the box. I'm just going to adjust my camera just a little bit. Okay, perfect. So you might notice that this box, it's got a couple holes in it, 4 holes in the top and then 1 in the back. This box is meant to be your first project box. You don't need to make anything else. You don't need to make an enclosure. You don't need to 3D print anything. So you can just you can house the whole thing in this box. That means it's great for very limited space. Like, I've always got a million projects on the go on my desk. This fits in such a small space. Like, look, it's the size of my hand. That's how cool. That's sweet. All right, let's get this open and see what we get. Okay. So inside, you get a bundle of wires. So first off, there's this box here. There's the Phidgets hub. We'll get to that in a minute. You get a USB cable, of course. These are important. Nice long one, too. I really appreciate that. You get 2 LEDs, actually. So we get a red and a green LED, and you'll see that they've actually got little tape to label which one's red, which one's green. And you get 2 big arcade buttons. How cool is that? Nice and clicky, really clicky arcade buttons. I love these. All right, so we've got our 2 LEDs, we've got our 2 buttons. What's in this box? Let's get this box opened up. I love the way that they package this all up too. I'm super excited. I just want to write the code now. Okay, so we get rid of the box, and in here we've got our VINT hub Phidget. So what is this? This is a central hub. This is what you can connect all of your devices to. So and the V stands for versatile. So normally, like again, say on an Arduino, you'd have to program some pins to be either input or output. On this, you can basically just say in software what each of these ports does. So for example, so like any of these ports can be input, any of these ports can be output. So for instance, in your software, you can say, when we write the code in a minute, you can say that on port 0, that is connected to a button. So we can define that in our software. And then you could say, okay, port 1 is connected to my LED. Cool, right? Okay. And then again, this is all meant to fit inside your project box. So you put your hub in here, feed your USB cable through here, install these buttons into the lid. These buttons are threaded, so you can unscrew this and get your buttons into the lid. And same with your LEDs. Now, like any good cooking show, because that part, getting this part off is just a little bit fiddly. Like any good cooking show, I've got a demo already prepared. So I've actually gone ahead and put this particular box together already. So this is my completed Phidgets box. And you can see that I've got my 2 buttons. 2 clicky buttons are awesome. And 2 LEDs on here. And I should actually crack this open and see. And you'll see once everything's wired up inside, it does look like a little bit of a mess, but just bear with me here. And I've also threaded my USB cable through here. So I've got a USB cable that's permanently attached. Really nice. Okay, let's take a look. So, and I'll sketch it out here on this surface. This is actually a whiteboard surface. So if we take a look here, it looks like port 0 is connected to the red button. So port 0 is red. Oh dear, it's flipped. That's okay. Port 1 is connected to the green button. 2 is connected to the red LED. And 3 is connected to the green LED. So just as a reminder, so this is our current setup for this particular hub. So port 0 on this hub. So port 0 on this hub is connected to our red button. Port 1 is connected to our green button. Port 2 is connected to our red LED. And port 3 is connected to our green LED. Okay. Now you can have multiple Phidgets connected to your computer. So if you've got a bunch of these, you can connect a bunch of these different hubs up to your computer. The serial number is on the back of these, and this is what you can use in software to actually say, this is the Phidget that I want to work with. This is the Phidget hub I want to work with. And then you'll see I've got 2 other wires here that are coming off. These are for other attachments that we'll cover in another stream sometime down the road. So, you know what? I've been talking enough. I want to write some code because this thing is cool. So let's do that. All right, so first thing we're going to do is I'm going to move over to Visual Studio here. This is where we're going to start to have some fun. And like I said, our red button is on port 0 and our green button is on port 1. Now, before we even write any code, we could actually use a piece of software that comes with the Phidgets to explore the Phidgets a little bit. So what do I mean by that? Well, there's this awesome piece of software called the Phidget Control Panel that comes with when you go to the Phidgets website and download their software and their software development kit. So I'm going to plug in my Phidget box here. Just plug straight into USB, and you'll see that I get this 6-port USB Vint Hub Phidget pop up. 6-port USB Vint Hub Phidget pop up. So check this out. Remember I said that on port 2 on the hub, I had an LED hooked up. Now we can use this LED by taking a look at this, at what's called digital output mode. So I'm going to double click on this, and I'm going to say, this shows me that I'm on channel 0, hub port 2, and the hub that I'm connecting to, 561.995. I'm going to click the button turn on. Notice that that turned on the LED, and then I can hit turn off, and then it'll turn it off as well. So on, off, on, off, on, off, on, off. And we can do the same thing because we said port 3 is our green LED. We go to digital output mode, on, off, on, off. Isn't that cool? And again, we haven't written any code. We haven't needed to do any sort of crazy setup. We haven't needed to create an electronic circuit to make this work. We are just using, we've just connected up to the Phidgets hub. That's all we've done here. And then port 0, remember we've got our red button is connected to port 0, and we can read that through the digital input mode. Now when I double click on this one, notice how it says state equals false. Check out what happens when I hit the button. That changes state equal true. Cool, right? And again, I can do the same thing with port 1. Awesome. Okay. So we know this thing works, and in fact, I'm going to keep this window. I don't think I'll need it for the time being, actually. How can we actually program for the for Phidgets? How we're going to program for this thing is we're going to use Visual Studio. We're going to use Visual Studio Community Edition 2019. And, you know, just the pretty standard install here. First thing what I've created here is a .NET Core 3 project. It's a console application. If I run it, if I run this Hello Phidgets, this will come up with a command prompt window, and all it does is write out Hello World. I'm going to bump up the font size so that we can all see what's going on here. Yeah, so all it does is say Hello World. That's actually a little bit too large. My apologies. Should have had this set up ahead of time, but hey, what are you going to do? Okay, so all this does is say Hello World. All right. To use Phidgets from Visual Studio and from C#, you'll want to right-click in your Solution Explorer, right-click on Dependencies, and click Manage NuGet Packages. And you'll want to browse for Phidgets, specifically phidgets22.net. Hit Install. This will add the Phidgets library to your program, and now we are ready to use Phidgets. So first thing I'm going to add in my program.cs, I'm going to add a reference to, I'm going to add a using statement for Phidgets, for Phidget22. I'm going to get rid of this Hello World, and I'm going to, first thing I want to do is control the red LED. So I'm going to say var red LED equals new digital output. Now this red LED is being driven off of a hub device. So I have to say red LED dot is hub port device equals true. And red LED, I need to specify the channel, hub port, and that was on 2. Then we'll scroll down a little bit here, and I'm going to say red LED dot state equals true. So it's either 1 or 0. And then I'm going to put in call to system.threading.thread.sleep. We'll sleep for 1 second. Dot state equals false. We'll sleep. So we're going to show the light for 1 second. We're going to sleep, wait that 1 second, and then we're going to turn the light off. So once we've defined our red LED here, we're also going to need to open it. We're going to need to open access to this device. So we're going to do red LED.open with a timeout of 1 second. So in other words, if we can't get access to this LED in 1 second, then we're going to just error out and exit. And then finally, at the end of the program, it is good practice to close your Phidgets. All right, so let's run this. I'm going to hit run. And we should see the red LED pop up. 1 second, off, done. That happened pretty quickly. Let's run it again. So check this out. I'm going to hit run. LED pops on, pops off, done. Now we could go one step further. We could make this thing blink. Watch this. So I'm going to say for var I equals 0, I less than 10, I plus plus. And I'm going to take all this code, I'm going to shove it in here and say, we're going to repeat this 10 times, and we're going to blink this pretty quickly. I'm going to say 500 milliseconds. Let's run it this time and see what happens. So it's happening pretty quick, and the reason it's happening pretty quick, there's a slight flicker, but I'm not putting in a sleep call after the red LED state equals false. So basically for a very split moment, I'm turning off the LED, but then as soon as we get back in a loop, I turn it back on again. So let's run this program again, and we should see the red LED blink. Yep, there we go. It's blinking once every 500 milliseconds. So, isn't that cool? Isn't that cool? All right, so we managed to make a simple program that turns on and off a light every 500 milliseconds. So what else can we do with this? Because you might be thinking, okay, well, you know, this is a great introduction to programming an embedded device, but I could just get my students to say, write, you know, like console.writeLine, hello world, and then get some input from the console with var input equals console.readLine. You know, I could get my input output this way. Okay, here's the thing. Making an LED blink and doing these kind of embedded projects is way cooler. And yeah, you can do stuff on the keyboard, but let's talk about what else you can add to your Phidget setup. So for example, when I got my kit from Phidgets, I also got with it a sonar sensor. So what is this thing? When hooked up to your code, you can actually get updates as to how far something is away from this Phidget. This works to something like 10 meters. It's crazy. So like it sends out an audio pulse, and the return of that pulse tells the Phidget how far away something is. And again, to wire this up, it does not require that much code. Same with something like this dial here. This dial has a button. You can click it, and it can spin indefinitely. So like for a simple robotics project, or for a simple project where you want to control how bright a light is, these are great little devices. These give you options that maybe your keyboard and mouse don't, and there's a little bit of a cool factor here. Let's be honest. These are a lot of fun to use, and it doesn't require any crazy wiring. Like let me compare what I've got here to something in my Arduino kit. So in my Arduino kit, I've also got a sonar module, but this has got 4 wires. I'm going to have to wire up some sort of electronic circuit to make this work, and then import a bunch of libraries. So there's quite a bit of work to it. The other thing that Phidgets has, and I don't have one right now, but I'm probably going to get my hands on one, is controllers for motors. So if you want to control something like I've got a couple I've got a stepper motor here and a DC motor. If you want to control these with an Arduino, you're pretty much going to have to get some sort of a controller circuit. Again, Phidgets has different Phidget modules that take care of all of that work for you. So all you have to do is connect some wires up, and you've added onto your system. You're not dealing with electronic circuits. You're not trying to diagnose why something's not working. You basically, you know, to hook up this sonar module, I'll give you an example of how to hook up the sonar module. We're going to do it right now. So to hook up the sonar module, I take one of my sets of wires, and I'm done. I'm ready to use the sonar module now. And it's a Sonar Phidget. It's just ready to go. And you'll notice on each of these different Phidgets, you may be able to see this, on each of these different Phidgets, it actually tells you on the Phidget the type of object that it is. This is a digital, this dial is a digital input and an encoder. And then this Sonar Phidget is a distance sensor. So there's no guessing at what library you need to use. Like on this is great. This is, you can control stepper motors with it on an Arduino, but you're going to have to wire this up yourself and guess which input is this going to be on, what kind of object, what kind of library do I need to use. With these Phidgets, all you need to do is clip this in, and then we can use a sonar. We can use a distance sensor to use it. Now this is hooked up to what? Port 4. Now let's go, actually, now that we've got that hooked up, notice in here in the Phidget control panel, this has already detected this as a Sonar Phidget. And now if we say, and now we can actually say like, how far away, whoops, it's saying saturation detected. I got too close. So notice how it's actually saying that my ceiling is, what's that, 1,470 millimeters away, something like that? Well, notice as I get my hand closer and closer, that, it's able to detect that it's only a couple of centimeters away. Isn't that cool? And then if I activate loud mode, it can actually get that much more accurate. So if I'm closer, it's saying it's probably around 90 millimeters or so. And again, we're able to use this without having to, do any complex circuit diagrams. Anyway, we'll do this, we'll play with the Sonar Phidget another day and the Dial Phidget another day. I just wanted to bring that up, that's one of the reasons you might want to use these Phidgets. It's just the ease of use of getting your students interested in electronics. Like there's just no barrier, the barrier to entry is so small. Okay, I've gone on and on enough about that. Let's do something else that's cool here. We're gonna eliminate all this code. We're gonna, I'm gonna get rid of this code for the time being. And what we're gonna do is we're going to write a program that when I press the green button, we're going to make the green LED light up. So what do we need to do here? First off, we need to make a digital input for my green button. I'm going to say var green button equals new digital input. Whoops. Really helpful if I could type. Green button is hub port device equals true. Now, I haven't actually explained why I know that I need to set this to true. Let me go back into the Phidget control panel for a second and bring up for port 1 the digital input mode. Notice in this window, I've got this little location button. If I click on this location button, this will actually tell me the exact parameters I need to tell my program in order to address this device. So for example, it tells me that the hub serial number is 561995. The hub port is number 1. The device channel is 0. And is hub port device is true. So that's how I know all these things. So green button dot hub port equals 1. And then my green LED is on hub port 3. So I'm going to say green LED, var green LED equals new digital output. Whoops. Pressed a few too many buttons on that one. My apologies. Green LED dot is hub port device equals true. Green LED dot hub port equals 3. This is how excited I am. I can't type. Okay, so green button dot open with a 1 second timeout and green LED dot open 1000. Then I'm going to add a console dot write line, press enter to exit. And I'm going to add a console dot read line. Then once we press enter, I'll say green button dot close and green LED dot close. Now, at this point, we haven't actually done anything. If we run this program, nothing's going to happen. So I'll run it right now, and I'll press the heck out of this green button. Nothing's happening, right? We haven't told, so how do we actually use the digital input? Check this out, green button dot state change. We're gonna say, so state change is an event. So we can give it an event handler. And notice that when I say plus equals, Visual Studio is asking me, press tab to insert a new event handler. Now, I'm using a plugin called CodeRush, so this is, otherwise you would just be able to accept the default name and rename this later. I'm going to say on green button pressed. Actually, in fact, to make this a little bit simpler, I'm going to step back a little bit. My apologies here. To make this a little bit simpler, we're actually going to make this a lambda expression. So check this out. Lambda expression plus equals open and close bracket OE equals greater than sign. So what we've done is we've made an event handler for this state change. Now, what is O and what is E? So in .NET, you'll see a lot of times this, in the eventing model, you'll see this. Each event will basically have a signature with the sender, the object that raised the event, and the E, which is the event arguments. So check this out. So E dot, and now I see I've one of my options here, or one of my fields that I can read here from the event is, the event arguments is state. So watch this. Here's what I'm going to do. I will say if, because this is going to fire when this state changes. So I'm going to say if e.state, so if that is true, if e.state is true, then we're going to say green LED.state equals true. Else, green LED.state equals false. Now, I don't need to be this verbose because e.state is a Boolean variable and green LED.state is a Boolean variable. So I could just say green LED.state equals e.state, right? Let's test it. Now, if I press the green LED, if I press the green button, that should light up the green LED. Oh, it does! Look at that! Isn't that cool? Isn't that just the coolest? Okay, and now that the program has stopped running, notice how it doesn't light it up anymore. Okay, now we're on to something really cool. We're going to do something else now with the red button. What are we going to do? Well, I got a special surprise for you. In the latest version of .NET Core, it is now possible for you to write programs that target something called Windows Forms. So what I've done is I've opened up the project file for my Hello Phidgets project. I'm saying that the SDK I'm using is now the Microsoft.NET SDK Windows Desktop, all case sensitive, and that I'm going to say use Windows Forms is true. Why do I want to do this? Because when I press the red button, so I'm going to put red LED equals new digital input. Red LED dot is hub port device equals true, and red LED dot hub port, and that's on hub port 0. And finally, I got my red button equals new digital. Whoops, I got that the other way. I got that the wrong way. Did I? Oh, I did get that the wrong. I gave it the wrong name. I want to call this red button. So red button, digital input, red button, red button. Okay, so var red LED equals new digital output. Red LED dot is hub port device equals true, and red LED dot hub port equals, and that's on 2. That's on hub port 2. Okay. So now check this out. I'm going to open up. So red button dot open 1000. Green red LED dot open 1000. All right. And then finally at the bottom here, I'll add calls to close this. Red LED dot close. And then I'm going to hook up an event handler for the red button dot state change. Plus equals OE. I'm going to say that my red LED.state equals E.state. Now, I'm going to add in an if statement here. If E.state, So in other words, if the state is on, if the state is true, if I push this button, I'm going to do var sound equals new, and I need to just pull up some sample code from earlier because I was experimenting with this. Apparently I don't have it at the moment, so that is okay. Oh yes, I remember what it is. It is new sound player. And we are going to play Windows Media tada.wave. So we are going to, when we press the button, we're going to play the sound. So just to go through this, and I'm going to minimize these windows just for a second to give us the most surface area to work with. When I press the red button, I'm going to play the ta-da sound. Okay? So why did that show up? I've already got a using statement for system.media, and that's also the reason why I'm using Windows Forms and the Windows Desktop SDK so that I can play sounds on Windows. All right, let's run this. Okay. So green LED works as we expect. Red LED shows up. And you hear the ta-da sound. Isn't that cool? Isn't that just the coolest? We can just keep pressing this button and make ta-da, 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 ta-da. Oh, that's too cool. I don't know. Just getting a computer to respond to some sort of input that isn't the keyboard and mouse is just a ton of fun. Then again, I'm going to jump back into Visual Studio here. We've got a lot on here. But let me finish the program first, and then I can jump back in here. Okay. So, oh, I love this thing. Okay. So if we come back in here, like, so you can see, like, we can do a lot of really cool stuff with Phidgets. Like, you know, we're not just limited to saying, okay, we want to light up an LED. We can cause our computer to do stuff. Like, you know, we could say, you know, we could extend this and say if e.state, you know, what we're also going to do is say var random equals new random. So we're going to var next. So we're going to do console.writeLine. The next random number is this. Random.next. And we're going to say a number between 0 and 10. So we can use this red button to come up with random numbers. So check this out. Look at that. You've got a random number generator. Isn't that cool? Whack a button, get a random number. So, I mean, there's all sorts of possibilities that you can have with these Phidgets. You are not just limited to lighting up LEDs. You are only restricted by your imagination as to what you can do with these Phidgets. It is really cool. You could very easily hook this sonar sensor up that when something gets close, that you start turning on one of these LEDs. Like if it's far enough away, you turn on the LED, and if you turn on the green LED, and if it's too close, you turn on the red one. It's like, oh no, it's gonna be awful or something. I don't know. What the heck? Let's do it right now. I'm gonna hook this up. So just as a warning, I'm now coding blind. If this doesn't work, please don't, be nice or something. I'm gonna run this wire out the back of the box so that I'm not doing anything horrible to this box. I'm also going to update this board. So port 4 will be our sonar. So port 4 is now our sonar. Port 4 is going to have our sonar hooked up to it. And I'll hook up the sonar. Again, click like that. I'm going to put the sonar on the front of the box. Let's see. I want to be able to see the whole box here. Okay, cool. And then for reference, I've got a ruler here. For reference, I got a ruler here, and so to the edge of the board is about, so the edge of this whiteboard is about 20-ish. Let's see, about 24. So right around, actually, I just want to make sure this is visible. Here we go. Okay. Okay, perfect. There, now we can see. So the visible range goes to about here. So that's right around there is about 170 millimeters. So 17. Am I writing correctly? I can't tell. Oh, we can't actually see it there. Okay, well, that's a good sign. Anyway, so right about here. So right about here is about 160 millimeters. So, and we'll use. We need another object to measure. Yeah, this Phidgets box, this other Phidgets box will work quite nicely. Okay, so again, port 4 is our sonar. We're going to jump back into Visual Studio here. And I'm going to set up another device. And I'm going to jump back into my Phidget control panel and get the reference information here. So this is not a hub port device. This is a distance sensor, and it's on hub port 4. So var sense distance sense sonar. Let's just call it sonar. New distance sensor. Sonar.hubport equals 4. And we'll do sonar.open 1000. So if we can't get it in a second, then we'll just abort. And then finally, we'll come down here, sonar dot, what was it again? I think it was sonar dot distance change plus equals OE. Whoops, I missed using the equals and right angle bracket to give me a delegate. So E dot distance, okay. Cool, okay, and so on this one, I'm going to say if the distance is greater than, if E.distance greater than, and I think this will give me a measurement in millimeters. If distance greater than 100, I'm going to say my green LED.state equals true, and my red LED.state equals false. Else, green LED.state equals false, red LED.state equals true. Yeah, this is a really good opportunity to get your students thinking about simplifying their code, because I could very easily say, you know, this is also equivalent to the following code. So green LED.state is equal to if E.distance is greater than 100, and red LED.state is equal to E.distance is less than or equal to 100. Right? So these two statements are functionally equivalent to this if block. I'm going to use the if block just to be very, very explicit in this example. Okay, and let's try running this. This should work. Again, I'm coding blind here, but, you know, I've been known to get stuff right on occasion. Okay, we see that the green LED has lit up. And again, the green LED, if I bring my hand in front, oh no! And it's gone. Look at that. Oh! Yep. Oh, yep, cool. All right, and then we've got the box. So at present, it's about, the other box is about 160 millimeters away. I'm going to bring it to 150, 140, 130, 120, 110, 100, 90. Oh, 90. Oh, so if we account for how recessed this, the sensor actually is, so right now you can see right here, it is kind of bouncing, it's right on the edge. Like I'm going to move it just a little bit away, and you'll see that it's actually like, it's kind of reciprocating back and forth. Because depending on where exactly you're talking about, it's right on the edge. I would say it's about, based on where the sensor depth, it's about 100 millimeters away. Again, if I move it very far away, it's, we got the green LED on. If I move it really close, just really suddenly, we see the red LED come on. So again, there we go. So in this case, we're just saturating, you know, we're saturating the thing. And again, move it away, there you go. Isn't that cool? And then our old button press still works. So I can press this. Ding, look at that. We got a random number and we did. Ta-da. Oh, that's cool. Okay. So I will publish this code on GitHub because I think I'm going to stop it there for tonight. I will publish this code on GitHub. What is my GitHub again? So github.com. I'm just checking out where my GitHub actually is. If you want to follow me on Twitter, easiest place to follow me on Twitter is at agfin. I'll bring up the relevant details here. If you want to follow me on Twitter, you can follow me on Twitter at agfin. If you want to subscribe to, if you want to view my GitHub, where I'll put this code, you can go to github.com/EliasPerunin. And then shameless plug. Shameless plug. I wrote a book. You can find the book, the really awesome, epic book, and not just because I wrote it, it's because I do truly think this is important. You can find my new book, Beyond Passwords book, at www.beyondpasswordsbook.com, https://www.beyondpasswordsbook.com. And if you want to get started with Phidgets, go to phidgets.com, click on the education link. I believe they have a link here that says sign up here for 2 free getting started kits. You can download the software libraries. And again, there are a ton of different devices here. There's a lot of supported languages. You don't have to use C#. You can use JavaScript, VBNet, Objective-C, Python, Java. Use pretty much anything. There's robotics kits. There's sensors for pH. There's a touch wheel. There's an RFID reader and writer. That's really cool. They've got a ton of they've also got Phidgets for controlling DC motors and stepper motors. So that just about wraps it up. I thank you very much for tuning into the live stream tonight. Hope you found this valuable. I will also post this on my YouTube channel, and when that's available, I will tweet it out. Best place to find me, though, is on Twitter at agfin. Thank you so much for tuning in. Have a wonderful evening, or morning, or afternoon, depending on where you are in the world. But thank you for watching.